So the question being asked is, how do I come up with the graph of the derivative based on the function? So why don't we start with some things we know. First, if we would consider y equals x squared, then we know the derivative is equal to 2x. And this is an expression for the value of the slope at all inputs. So that means that when x is 0, y prime is also 0. And when x is 1, y prime is 2. And when x is negative 1, y prime is negative 2. We can graph that. We know that's linear. But let's try and make sense of this only from the graph of y equals x squared. So y equals x squared, you know, it's a parabola whose vertex is at 0, 0. What does the graph of the derivative look like? Now remember that y prime is telling you information about the slope of the tangent lines at any particular x value. So I know that the tangent line at x equals 0 is a horizontal line, which means its slope is 0, which is why the value of the derivative at that point would also be 0. And I can see that if I were to continue to sketch in a variety of lines to the right of the origin on the original function, I have lines that get steeper and are going up, which means their slopes are positive and increasing. So it's fair to say that if the slope at this point is 0, then at some point to the right it would be 1, at some other point to the right it would be 2, and just continue in that way. And specifically, we would find that at the x value 1/2, the value of the slope would be 1. How can we confirm that? Well, we know the derivative is 2x, and when I plug 1/2 the x value into that, I get 1. And I also know that when the x value is 1, the slope will be 2. Why do I know that? Because I'm seeing it's getting steeper, and I can verify that by knowing the derivative function. Right? So this is clearly linear with a slope of 2. I can see the same thing to the left. The tangent line at this point would look something like this. Clearly it's going down, so its slope must be negative. At this point, it's also going down and steeper, so it's more negative. So that means that the values of the slopes are getting negative as my x values go to the left, and they're getting more and more negative because the tangent lines are getting steeper. And that's the principle. Although that is a tricky thing to think about, and it's even more difficult to start from the derivative and consider the original function, right? And both are crucial ideas to be able to do. So try this. You know that if y equals sine of x, you already know that the derivative must be cosine of x. Right? You should have that memorized, or at least be aware that that's the case. Go ahead and make sense of why that must be the case by looking at the graph of sine over one period. Right? So we know that sine starts at 0, 0, reaches a maximum of a 1 at pi halves, heads back down and crosses over at pi, reaches a local minimum at 3 pi halves, and then returns and finishes the period at 2 pi. Sketch the derivative based on what you're seeing. So actually pause the video, see if you can sketch the derivative based on that function. Now if you've done that, what you ought to notice is that the horizontal tangents would occur here and here, which means the value of the derivative would be 0 at pi halves. And 3 pi halves. And that also means that before pi halves, the tangent lines are going up, so their slopes are positive, but they're getting closer to 0. So it would be doing something like this. After pi halves, the tangent lines are going down, and they're getting steeper. So they're doing something like this. At this point, they're heading back to 0, but they're still negative. So notice my outputs of my derivative are negative, but they're getting closer and closer to 0. Now they actually are 0. My tangent lines are going up, so the slope is positive, and they're getting steeper again. So right now it's 0. Now my slope is positive, and it's getting higher and higher and higher. And we do in fact have a cosine graph. So that's the idea behind starting from a function and sketching its derivative. And a good thing you could do with your friends there is you could have each of you could just make up a graph. It doesn't even have to you don't even need to know the equation, but actually just sketch on a piece of paper a function. Pass it to the person on your right, or pass it to somebody else. That person needs to sketch the graph of the derivative on a separate piece of paper. Then send the derivative with the original function underneath it so the next person can't see it, and see if the other person can take from the derivative, sketch the original function, and go backwards. And when you guys can do that fluently, you're doing a good job.